technology can improve our lives. Okay, not in a social way. We are going to talk about how technology can improve our lives in healthcare. Okay. Healthcare is a large ecosystem, vast and complicated. There's cardiac care, there's operating room, electronic medical records, clinical decision support. That would be maybe the nurse you are talking to when you go to a hospital. Imaging and diagnostics, like RMNS, CT, and lots of other stuff that can get pretty easily into chaos if not treated well. We chose the operating room as a use case to our presentation to see how we could help the surgeons improve their flow during the operations. Okay, this is a quote from my colleague here. Who are we? We are two developers or software engineers or weirdos who are at our keyboards. And we are here because we are passionate about technology, about writing code, and about making something that's useful to the other people who don't wear out keyboards writing code. Okay, IoT, because in the operating room there are mostly things and a couple of people. IoT is Internet of Things, and in this use case it's called Internet of Medical Things. Basically, you can put a small computer into a refrigerator, washing machine, into your car, into an operating room table maybe, and connect it to the internet to make it do useful things. This is a graph with an estimation of the market in IoT. Okay. There are lots of money involved. And IoT, as we can see, I guess, it's here to stay. It's not a buzzword anymore, as it was a couple of years ago. You can see on the market already billions of home security cameras that are connected to the internet, cars, and even refrigerators, light bulbs, and washing machines. Okay, these are some drivers of why would you need IoT in healthcare. So connected things, doing automated stuff and not requiring human interventions could improve the overall flow of healthcare. The two images to the left, you can see chaos. So a patient has to go through different stages and to different places in its healthcare endeavor. And what technology can do, it can bring all the chaos to a circle of order, I'd say. As I said, we chose the operating room as a use case to present our application. Okay. Our UX researchers interviewed some surgeons in the United States. So that's what they said. What they need in the operating room are pretty simple stuff at the beginning. They would need a way to call people, like calling the nurse to get the chainsaw or something. Maybe controlling some lights or other devices without leaving the room or without leaving the sterile zone. And some simple way to check the time, ask maybe a robot for how much time the operation is going on, stuff like that. These are three things we try to have in mind when implemented our application. Okay, and I'll let Matei talk about the technology behind.
Thank you, Florin. As you can see, the stuff is pretty simple. Even Dodge is amazed. So let's go fix it. Now, you know an application has a front end, a back end, and a database. That's pretty basic stuff. The front end is designed for the customer's needs, so that usually changes. But what doesn't change is the database and the backend. Now, for that, we made some time ago a system which we call the Hive. Now we call that Half Connect because, well, marketing. As I said, a typical software looks like this with front-end apps and back-end apps. What Hive does to this is it replaces the back-end. Now, Hive or Half Connect, you'll hear me use Hive, Half Connect, MHC interchangeably. It's the same thing. It's referring to the same thing. So it enables you to leverage AI and data analytics. It allows you to, well, to gather data from many places by using a common data model and other marketing stuff. It's great, trust me. Where could we use Hive? Well, the client comes to us for a healthcare solution. Now, what we do, we get Hive, we deploy it in Azure, and we use it as a scalable and secure platform. Some examples of apps developed using Hive are a decision support tool, which is AI assisted, a Parkinson's patient management platform, and a research sharing platform. Now, Hive introduces a new model where you have bees, which are the external apps. I think you can now understand why it's called Hive. It has cells, which are processes and things happening inside the Hive. Honey, which is the language to describe the application, the business logic. Honeycomb, where you describe how the data looks. Reactions, cells generate reactions, like you add something to the database, and the database says, okay, it's created, that's a reaction. Actions are entry points in Hive, and the behavior is the behavior is what the cell does. Now, for context, this is how a honey and a comp file looks. It's another language. You might say it's cumbersome. It's okay. It shares some resemblance to JavaScript for those who are so inclined. And this is how the system actually looks. Now, Hive is a reactive system. That means it scales with your needs. Like, take into account that you might have 10 users asking for data. That's fine. You have 100 users asking for data. That's also fine. But what if you have 10,000? That's a lot. And that's where Hive scales, and it makes more storage services to give you the information faster. Now, everything from the B app goes to the load balancer, which then calls the authentication server, the shell or reaction service, and everything is interconnected. Now, to create instances in Hive, you go from the B app through the load balancer to the shell service, which is when you make a call. Then it goes to the core cell, which authorizes you, goes back, goes to the storage service, which says, okay, I can give you the data, goes to the database, gets the data, and creates the data, and then creates a reaction, which goes back to the B app. To get the data, it's similar, you go to the authorization service, it says, okay, then goes to the storage server, get the data, and the data returns. Now, Hive is really secure. So secure that even we get locked out of it on occasion. So take that as you want. It's HIPAA compliant for those interested. It's great stuff. Now, let's make a small demo in Hive to present you how it works. You're gonna have to give me a moment. I cannot see my cursor. Here. Okay. So, first of all, let's create a blank application. That would be in the OR demo folder. We do that by creating 2 new files. This is extremely awkward to do, new file. So let's call it app.honey. Spell that correctly, thank you. And my microphone is falling off. And let's create another one, which is the com file. So app.com. Okay. One thing we have to set is the namespace of the com file. So namespace, if I can spell, or app demo. Save that. Now we have to push the application to Hive. That's pretty simple. You just use the CLI. So ACLI app or app, damn it. ACLI app or app demo dot. Okay. So now the application is pushed to Hive. Now, yeah, the application is empty. You cannot do anything. But you can check its existence using the Hive shell, if I can get there. So Hive shell apps. As you can see, our app demo is there. So let's connect to it. Okay. Now, you need to have users in an app, right? As you can see, there are none. Sorry. There are none. So we could create one using this command. Hopefully. I forgot to pray to the demo gods, I'm sorry. So users, add the email, so app@app.com, it's fine. App user name, app user pass. Okay, this is an issue. Let me just check something. Okay, so the demo gods aren't with us today. I think I have to invite Florin.
You're not authorized.
Sorry?
You're not authorized to do.
Yeah, I know that.
So?
It might be the network, although I checked. I have to invite Florin till I debug this and we'll go on from there. Yes, let's go.
Okay. While Matei will debug his application, I'm going to show you how we implemented a client for this backend. We have an existing application in Hive, so we are going to use that. Okay. I'll show you the application first and then the demo. I used Node-RED because what we did with this application was, at least for this part, basically connecting a couple of services together. So we have the Hive for backend, for storing the data. We have a natural language processing service, which is Dialogflow from Google. It's the same technology behind Google Home speaker and Google Assistant on Android phones. Okay. First of all, the init of the application. Basically, I do some authentication in Hive. Okay, I configure the NLP endpoint to call to get the natural language process data, and then some initialization for the SMS sending actions. This is a flow I created to add patients and see the list of patients. And this is the flow for the voice application. How many of you are recognize this interface? Okay. This is Node-RED. It's an open source technology. It's built on Node.js. It's developed by IBM. It runs, being a Node.js application, it runs on any environment, like Linux, Mac, Windows. It's a flow programming environment. The flow programming was also invented at IBM in the 60s, I think. Basically, you have a bunch of blocks, like Lego blocks, and you can connect those together to do a bigger thing. And I'll walk you through this flow. But first of all, I'll show you just the Node-RED website. I say maybe you can take some notes on the keywords we use, and you can just do some Google searches to see more later. Low-code programming for event-driven application. Okay, it's a very cool technology. You can also install it on a Raspberry Pi. How many of you know what Raspberry Pi is? Okay, that's better. So use it with your Raspberry Pi and you'll become a god of programming. Okay, in Node-RED, you have lots of nodes you can use out of the box for different use cases. For example, you can create a web server just by dragging an HTTP in node, editing its endpoint, and then do some actions and use an HTTP response to return the response. I will show you how I use this node. I'll start with the patient's flow. Basically, here I have a node where I added some HTML. It's a template node. I can show you how it looks in the interface. You also have a UI interface with Node-RED. It's a very ugly interface, but you can make it prettier. Here I can create a new patient. Choose what interventions did the patient suffer. Save it. It will be sent to the Hive, and here it is, created in the Hive. The flow is basically HTML with Angular directives. So it's just a simple UI. When I submit that save button, it will exit the node, the template node, and go to the next node I connected these two. This is a function node. You can create it by just searching for function node and start writing JavaScript code here. And the message returned will be passed to the output of this node and sent to the next node. This is another function node that prepares the message for the Hive backend to be sent. And here I have a subflow. You can basically select a couple of nodes, and if you want to reuse those in other flows, you can create a subflow. Selection to subflow. This is what I did with our Hive nodes. I created a subflow to reuse in the whole application. This node, it's a custom node implemented by Matei. In Node-RED, you can implement your own custom nodes following a recipe on the Node-RED website. Basically, you write a HTML file and a JavaScript file, and you do an npm install, and you can find then your node in your nodes palette in Node-RED. You just drag it and use it like any other nodes. Maybe I will show you later what's inside the node. For now, it's just a black box because we don't care what's in the backend. We just want to implement our application. Okay, the other parts of the flow here. Once I call the Hive action to create a patient, I go to a debug node to see the output, and also I send the output of this node to another flow that calls again the Hive to get the list of patients. So here I used a subflow with that node, and I just sent to it another input, call query, and some parameters. And another template node to display its HTML table to display our patient information. I use this flow mainly to create a couple of patients to use with the OR bot application, which is our simulation of a voice-controlled device. It can be just a speaker, or it can be a screen that would be in the operating room and assist the surgeon with maybe simple actions at the beginning, but I guess it would evolve. Just a sec. So one use case we try to implement is to open a DICOM viewer. DICOM is digital imaging for medical systems, something like that. And we use just an existing one on the internet. And I need to authenticate before showing it to you, because otherwise it won't work. Yeah, authenticate in the demo. Okay, back to our flow. So what we have here, first of all, the entry is an endpoint. I created an HTTP endpoint to the entire flow. This will get some text, like call nurse Matei, or something like that. And it will go further to the flow, to the NLP service. This NLP service is just a simple Python script that runs a Flask server. Maybe I can show it to you. And makes a call to Dialogflow API to get a JSON response with data obtained from the simple text. It's not much to see here. Basically, I just installed the library from Dialogflow, the Python library. I import it, and I created the method to use with my NLP endpoint to make a call to that service and return the response. Again, these are keywords you can search later on the internet and see how you can use the technology. And the service, which is called from Node-RED. Sorry, this. Yeah, it's just a simple Flask endpoint that gets some text, does the call to the NLP service, Dialogflow, and then returns the response to the Node-RED application. This is already running. So an example of what I obtained earlier, I asked for the patient age and it returned this information. It returns basically a JSON with all kinds of data like the action, the query that was sent, some parameters that it identified in the text. I asked what is the patient age and it extracted those parameters from my question. And the action, which I can use further in my application to do some processing on it. Okay, so we are here, this node, NLP. It responded with my JSON. I have a function node that saves the response from the NLP in another JavaScript object, because this message is passed around the nodes, and it may lose its information if you're not storing it in some special property. So I use this property to just save the data from the NLP to use it later in the flow. This is a switch node. It's like any programming switch logic. You can add the name of the property to check, and all kinds of values to check for. And it will grow with as many outputs as values you added here. So in this case, for example, Dialogflow response may return this parameter or required params present. There's a notion in NLP technologies of slot filling. So for example, I ask, let's say, I need some info about the patient, and I train the bot to recognize that I'm asking for information about the patient, but it won't understand what exactly I need. So it will send this parameter or required params present to false. So my application will understand that I need more information for the NLP to understand what it needs to do. And if it's false, it means that my NLP got all its parameters and I can go further in my flow to obtain the required information. So let's go to the false node. If the required parameters are not present, I'm building a response for my client. My client will actually be my phone. And I will respond with the fulfillment text, which may be something like, okay, what do you need to know? Or something like that. And I will then go back to the beginning of the flow with another input. For example, if my application asks, what do you need to know about the patient? I will say, okay, you need to know his age. It will go back to this, to the NLP service, and understand that I asked for its age. And then return another complete response with all the parameters that were required. The more complex scenario is where we have all the required parameters and we can go further into a more complex logic. Here is another switch. I added 4 actions returned by the NLP. These are some actions we implemented. For example, play radio can be an action. We don't go to the end with this. We have send SMS action, request patient info action, and we can follow each of these outputs and see some interesting responses. For example, for the get patient info action, I have a bunch of other function nodes that do processing. Yeah, this is an old one, not using. Here I build a query for the Hive to get the patient information, and I send it the patient ID for that information I need. I use that Hive subflow I created to call the Hive, getting the response from the Hive, building some response here. Okay, so here I get what actual detail was asked. I set a flag that I want a custom response, so I won't use the default response from the natural language processing service. I parse the response from the Hive to get the patient information. I will show you how it looks a bit later. And just set the response with this information. So this is a simple response. It will say something like, for example, if requested info is age, it will say age and the detail, which will be maybe 20 or 10 or whatever age the patient has. And then I return the response to the client application with an HTTP output node. Okay, another use case I implemented just to test it was to show an image on the screen. It's not done now. Basically, when the natural language processing identified that I want to see an image, for example, maybe the surgeon would like to remind himself of the circulatory system or something like that, it can ask the device just to project on the screen that information. Another one would be to open that digital medical imaging viewer, that icon. Or it can send maybe an SMS to the nurse to get the forceps or chainsaw. This small part of the flow initializes the interface of the application. Basically, I get all the patients in the Hive, and I select one for the operating room to use with the assistant. The interface is very simple. So I was thinking something like the surgeon would select his patient, and then use just his voice to interact with the bot to get all the information he needs. Okay, I will try now to show you a demo of the voice assistant. I use my phone to do that, but this can be a Google Home speaker, Google Alexa, or just some smart display that has a microphone. I wanted to hear what it responds, if it will work, so I use this small speaker. What's the patient age? You can see here the debug. The debug node printed what I asked. It's requesting the NLP service, which may be blocked because I had this open. I got the response. Also, I'm printing it using some debug node in the flows. I guess you heard what, it wasn't connected to my speaker. I'm going to ask what the interventions did the patient have. What interventions did the patient have? Okay, so these are the outputs of the flow. This text is from this debug node. You can use debug nodes all over the flows to see the data going from node, going out from node. I'm going to add a debug node to the NLP output. And also I'm going to add the text input to my application because I don't want to use my voice anymore. Basically, to implement an interface in Node-RED, when you first install Node-RED, you have to go to Manage Palette. And here you have lots of nodes you can install. And what I installed for the interface is install nodes. Node-RED dashboard. Other nodes could be Azure Blob Storage, SQLite. This is our node. The Hive, it's
Lightweight B.
Hive B library. Okay. Let's see. I don't know. Stuff from IBM. Stuff from Azure, from IoT Hub to DocumentDB, Blob Storage, Event Hub, and all kinds of services you can connect. Basically, Node-RED is a very good tool to connect services together and do a very fast maybe MVP or demo. Okay, I said I will add a text input. I'm going to select the tab I want to show and the page. So here I have my ORBot interface. I'll call it NLP input. Okay, if I set the delay to a number, it will send one output at that interval, but I will set it to 0, so it will pass the output only when I press enter. And I'll send the output to my NLP service. Okay, let's see. Here I have the new input. Okay, I say open the DICOM viewer. So it opened my my DICOM viewer. You can do this stuff in a standalone application, so maybe you have your application with its own DICOM viewer, so you don't have to use the browser, and what you use here is just an exec node. It will execute a command in your terminal. So this is something you would type in your terminal and will work the same. I just start Chrome with the payload I sent to this node. And here in this function node, I set the URL to that web page it opened. And let's see how the response looks from the NLP. This was a very simple input, don't have any information. Let's see another one. Here is the information for a more complex question. Let's say it's complex. What I asked, the action it identified. It got all parameters, the intent, the detail I asked for, and some fulfillment text you can set by default for the service to respond to your input. So this query went through all the nodes, got to that switch, and identified that the action is get patient info and went through the flow I showed you earlier. Okay. Do you want to see how the NLP service looks like? I'll assume yes. So, as I said, we use dialog flow. This is something you would also use if you want to implement your own actions on your Google Home device. There are four big players I know about in this kind of technology. It's Google with Dialogflow, Amazon with Lex, the service behind Alexa. There's also Louis from Microsoft and IBM Watson from IBM. All these services basically offer just a different interface to the same kind of technologies, and they use the same terms, I'd say. Intents, entities, fulfillment, and integrations. The intents are basically just verbs. For example, it's require patient information, or open icon viewer, play radio, show image, require some tool. Entities are subjects you can create. For example, the patient detail entity has age, name, interventions. And you can define your application's requirements here in terms of language. And this, the technology behind it, the algorithms, will decide what you said from a simple text input and what you need, what information you need. You have all kinds of integrations. You can see here the Google Home speaker. Also, you can use Google Assistant on your phone. Other integrations are, you can see here, Facebook Messenger, Slack, Telegram, Twitter, Twilio, even Amazon Alexa. Okay, that's it with the flow, with the node-RED flow. Maybe we can look at the code for a very short while. Behind the node that Matei implemented.
I think that's fine, I can show it on mine.
Okay.
I got the Hive up and running.
Good.
Give me the keyboard, thank you. Okay. I'm sorry, I was the stupid one. I named it wrong. It happens a lot when, well, you present in front of people. Okay. Could you, please? Okay. So, as I was saying, the shell. Okay. One thing that's very useful with Hive is to have the logs. If I could find it, okay. This one here, of course. Thank you for those. Okay, so one very important thing with Hive, you have logs. So HCLI logs will show you everything that's happening. I managed to create the user and role, but well, you can see them. Where's my mouse? Here. You can see them here. If I say users, you'll see I have a user edit and it has the role app role. Now, to make an app, as I said, it's pretty simple. Let me get Visual Studio. Okay. So, First of all, let's define the database, how we want and what we want to store. In order to do that, you define a class like this. It's a class of type storage, so it stores. Thank you. It's named patient details, and the one is the version. Now, to define it, we open parentheses, and this is the body of the function. I'll just get it from here. This is extremely awkward to do. Okay, so that's how we defined our database. Now when we push the application, you have the database in the cloud, and it's all fun and games. You don't have to deploy a server and make tables and so on. To check that, did I save it? Save. Okay, so check that. Let's up the application again. Let's check the files, everything's okay. And you can see here in the logs that it received a new application and set up the class for the app. Now, to add entries to the table, you can make an action, which is in the honey file. You say action add patient details, and you give it the details. You might want to restrict that to be accessible only to people with a certain role. You do that, of course. You do that by telling it you need a role app role, and the thing that it wants is this call to the system cell, which essentially tells it, let's get the system cell in the namespace comp, call the method create. You want to create a patient details object, and these are the parameters. You also give it the user ID and the user roles, and these roles are enforced later on when you want to get that data. That's why I said you can get logged out of your data. To get user ID and user roles, we can define a small function that does that for us here. And to call that, you do this. So now you have user ID and roles, and you want to chain these two actions. Let me format this a bit. Okay. And now the actions are changed. You get the app ID and roles in the variables user ID and user roles, which are then passed to the comp create method. Now, if you save this and upload, you'll see that it sees the entry point, and you can see that in the demo, in the log as well, as new application received. Now, that's how you get the roles. You can see in Postman, you can troubleshoot this with Postman if you want. You have authentication. I have these set up, and I have some environment variables set up as well, so you don't have to see a very, very long URL. So to authenticate, you can see we have an access token. This gets automatically saved. And then you have the add patient details call, and I'll add a patient with ID 1, 50 years old, and the patient will have heart surgery and diabetes treatment. You send this, the app will respond immediately and generate a reaction when the entry is actually created. Now, to get that, because you might want to get your data back, you can do that with a query in the comp file, which you define by, query of type storage, same as the class. I'll name it get patient details by ID, and this is the ID we want to get. It's pretty simple to do. So, and okay. Now we want to filter the data. By default, it gets everything. We want to tell it, okay, only get patient details. And we also said we want to get one by ID. So let's say that ID is equal to entry ID. Save, and where's my mouse here? And deploy. Okay, everything's fine. Let's check it in Postman. So we added a patient. If we call get, it will get us that patient here. Now say that, I don't know, we misspelled something, or I know we want to erase that. Well, it's actually not that difficult to do, even if it appears so. We can set an action that does that. It looks like a lot, it's not. I just logged the ID, got the roles. I got the patient by ID and called destroy by its instance ID. So save that and upload the app again. Okay. And now if you try to delete it, call delete, send. Okay, it's responded with 200 again because we only queued the message and it's going to execute sometime later when it can. Now if you want to call get by ID again, it's gonna go no. Okay. If you have any questions, I feel free to ask. If not, I can go through the library code. It's pretty simple, but if you're interested, please. Okay, amazing. Okay. I cannot find my mouse, okay. So, the library I developed, it's here. And this is the Node-RED implementation for it. As Florin said, you have an HTML file where you only register the node, and the JavaScript file where you use Node-RED to create a function which gets called when input gets to your node. And then I go through a switch by function. Function is one field of the payload. It can be authenticate. It gets from the payload everything and sends it to this method, which is right here, which only composes the HTTP requests and sends it. Same thing happens for the call action, call query, and the reactions part. The reactions here are implemented using a socket, a WebSocket, on which you get the data back from Hive. Okay. I think this is it. Florin, do you have anything to add?
No. We expect questions. If you are interested in the technologies more, maybe here. Or...
Yes, please.
Other options would be any programming environment you are used to. We decided on Node-RED because it's more attractive visually. So for this presentation was a better option than just showing you some Python code or JavaScript or .NET. And it's very fast to implement small applications in Node-RED. and connect, as I said, connect services together.
Okay. Anyone else? I guess not. Thank you very much for your attention. Hope it was everything was okay. Thanks.
Thank you.
Excellent.
Maybe we'll manage tomorrow to have a Google Home speaker connected to our application. Maybe we'll see tomorrow, and you can check our stand and see if you have some cool technologies there. Okay, thanks for being here.